Today's lesson will focus on energy levels divided into sections. So as we saw, sodium has 11 electrons and is into the third energy level. First 2 electrons in the first energy level, because that's all it can hold. Second energy level holds 8, and then it has to move into the third energy level. The pattern of filling spots until they are full and moving on to the next energy level works great up and through atomic number 18, which is argon. Something funny happens when we get to potassium with the atomic number of 19. As you know, the first, second, and third energy levels can hold a total of 28 electrons when you add them all up. It would seem that all of the electrons of potassium could fill within the third energy level. But it doesn't. It turns out, however, that even though the third energy level has a total capacity of 18, only 8 spots are filled before the electrons begin filling the fourth energy level. Wonder why that is. So potassium looks like this. So we fill our first energy level with 2. We move up to 8 in the second energy level. And then we fill 8 seats in the third energy level. And we leave these ones empty and move on to the fourth energy level. Why is that? I don't know. Let's find out. Turns out that in addition to distinct energy levels that we have, each energy level is further divided into sections where electrons can be found. So in terms of our rows and the analogy we've been using, first row would have just 1 section, second row would have 2 sections, third row would have 3 sections, and the fourth row would have 4 sections. So then the energy level that it is has that many sections. They're equal. And the reason why that last electron from potassium begins filling the fourth energy level is because the first section of the fourth energy level is actually closer or lower energy than the last section. So if we have our circle, right, and we have our nucleus, remember that the electrons fill closer to the nucleus and then further away. So we make, this is kind of ugly, but we're going to try to figure it out here. So if we make our 4 levels, section 4 on this side that I'm coloring in is actually closer to the nucleus, remember, than section 3. So 1, 2 of this section. I'm just drawing you a picture here. This isn't exactly how it goes, but I'm just showing that section 4 over here is closer than section 3 down here in reality. That's why it stops filling that section and moves to the fourth section. So this is what it looks like with our chairs. So here's our bottom. If we have our nucleus, say our nucleus is way down here, okay? So you can see everything on this side is closer. And then here's that extra section that we were talking about with potassium. See how far away it is? This section is actually closer. See on my line? So this is closer and this is further away. And that is why we moved into the fourth energy level before filling the third energy level. Okay, so our nucleus is here. This is how they're kind of set up, like staggered into the sections. So this is, remember we said that energy level 2 has 2 sections. This is it right here. This is for 2. And energy level 3 has this one, and this one way over here. Okay? And then energy 4 has this one, and then there'll be another one up here for the fourth level. There's 4. So they're closer, and that is why they're filled that way. So here's another example of iron. So we fill our first energy level, our second, 2.2, which is the 2 plus the 6 to meet the 8. Then we go into the third section here, and we do section 3.2. So we get a total of 8 into the third energy level, and now we're moving to the fourth to fill that, because that's closer, remember? Well, there's still room left over, right? So when you add them up, you have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. When we move into the fourth energy level before filling the third, this only gets us to 20. So our next section that's closest to the nucleus is back into the third row. And we fill up the other 6 in the third row. So iron has 26 electrons and has 4 energy levels, but doesn't even fill the third energy level completely before moving on. But it still has 4 energy levels. So what does all this mean? So understanding how electrons fill energy levels can help us to understand why the periodic table has as many rows as it does. Each row can roughly be thought of as starting a new energy level. As we proceed across the rows, electrons fill energy levels in sections according to where they can be at the lowest energy. So again, we have all these rows, and they start based on how they can fill. So even though potassium starts our 4th energy level, it didn't necessarily fill the 3rd one, but it's in the 4th row and has 4 energy levels. So moving your way down, this one is going to have 5, 6, 7, right? They may not all be filled, all their sections, but they're going to have that many energy levels. So sodium doesn't fall right beside neon. Here's neon right here. Even though it's number 10 and sodium is number 11, right here, this is our sodium. They're not side by side because sodium pushes into that 3rd energy level. And that's why it's moved way over here. I like to draw lines today. And it starts its new row because we know that's going to have 3 energy levels. The periodic table was designed so that the first electron starting a new energy level starts a new row. And each new row after that, after the outer energy level, has 8 electrons. So remember, they're broken into sections. So once you fill up 8, it moves into the 4th energy level. Remember how we did sodium and then we moved on to potassium, 4th energy, so 4 energy levels, but we still didn't fill the whole 3rd one because we needed to have it at its lowest, remember, lowest energy level first. Okay, low energy. It all sounds a little confusing, but it makes sense if you think about the sections being further away, if you remember how our seating chart was.